I'm from the United States, and in America, we're used to more interactive presentations where, people, maybe I ask you questions and you ask me questions. Um, if you use this hashtag down on the bottom of the screen, that'll actually show up on my display. So if I go too fast or you don't understand what I'm saying, then feel free to just send me a tweet to that hashtag, and if I don't get to your questions, I'll handle them at the end or be out in the lobby. I wrote that tool at the hackathon last night, so it's still sort of experimental. We'll see if it works. So I'm talking about UI testing sucks. So who am I? Why are you here? I don't know how many of you have read this article, Why Mobile Web Apps Are Slow. Anyone did their homework? Raise your hand if you've read this. All right, so I wrote this. About 400,000 people read it, which is quite a few. And so if you didn't read this article, that's okay. It has nothing to do with today's talk. But I'm kind of a complainer because I wrote sort of 10,000 words complaining about what's going on in mobile development. And so this talk is kind of similar, that basically I'm going to complain and not necessarily present a great many solutions. So I'm sorry, but that's the talk you walked into. So these are testing tools. These are UI testing tools. How many people have used tools like this? Maybe. Okay. So I am an iOS developer, so some of the stuff you're going to see here is iOS-specific code, but it's pretty extendable. There are sort of similar things on other platforms. How many people here are using one of these tools right now, in your project? Okay, maybe a third, that's all right. So if you are using one of these right now, then maybe you'll learn something that will be useful to you. If you're not, then maybe you'll learn some things to avoid. So these are quite a few tools, and actually there are many more that wouldn't fit on this slide. And so we have enough tools. If you are writing a UI testing tool right now, stop, please. We have quite enough of them. So just to back up, to make sure everybody knows what we're talking about, if you've never used one of those before, this is similar to John's talk right before lunch, where he was talking about unit testing. We're going to talk about UI testing, which is going all the way from pixel to pixel. So when you tap a button, right, generating some kind of UI event, maybe in a scripting language or maybe in Objective-C, and then having that run all the way out, hit a real production server, and getting that result, and sort of saying, does this user interface look what I expect? Did I load the data? Does that all look okay? And that's kind of a nice idea, right? Because we'd all like to test stuff by looking at the user interface, because the user interface is easy. And everybody sort of knows what it's supposed to look like. You don't have to know sort of what's going on under the hood. Maybe you have a mess of a code base, and so it's a really attractive idea. And so what happens is, you guys know this guy, Martin Luther King? I have a dream, right? So many of us, when we embark on sort of a UI testing adventure, we also have a dream about how it's going to go. We have a dream that one day software is judged not by the whims of our project manager, but by the acceptance test suite. That would be really nice if we have sort of objective standards for what our software is supposed to do. Another thing that would be great is if we had an automated test suite that eliminates the need for QA personnel, so we can just fire them all and produce products much more cheaply. Another great idea is if we could write failing tests for every bug, which would give us test coverage, and so we wouldn't have to retest every time we did a new release. And that as our test suite grows, it'll be easy to fix regressions that we'll know about immediately, because the continuous integration server will fail to build and send an email and say, John, why did you check this in? That was not a good idea. How many people have these kind of goals in your testing life, right? So this would be great. Unfortunately for you, these are all lies. You can't do any of this, and we're going to talk about why. So first, I have to give you a disclaimer for this talk. people approach UI testing in very different ways. And the way that most iOS developers and most mobile developers approach it is from the perspective of a small company, because most software that's developed for iOS is developed by small companies. And so you probably have maybe 3, 5, 6, 7 people in your company. And if you don't, pretend you do, because that's what we're going to talk about in this talk. So you're probably on this side of the chart. And there's a probability cloud that depends on sort of how large your company is that will determine whether or not you have real QA engineers. So like somebody whose full-time job it is to test software and write a test plan and make sure everything is okay. If you have a larger company, you're more likely to have a QA department. However, for the purposes of this talk, you don't, because you're a 4.5-person company. And at best, maybe there's somebody who sort of wrangles a beta test. How many people does that, that actually describe sort of your company pretty closely? All right, so we've got maybe 50%. Right, so if that's not you, it is now. So deal with it. So I'm going to tell you about this is a real software application. I'm not showing you real screenshots because I can't tell you which one it was, but I'm going to show you some things that are very similar. So this was for a large insurance company in North America, and you get in an accident and you sort of fill out some information about what, who hit you and what their name is and where we can find them, and you send that to your insurance company, and they pay you money, hopefully. And so it was a iOS product, and it looked kind of like this. So you'd fill out some information, and there's a flow depending on the questions that you ask. You get sort of different phases in the flow that you have to go through. And so one of the questions that we would ask you very early on is how many passengers are in your car, because for each passenger we have to collect information for that person. And so that's sort of the number of screens we have to display that collect information for people. So if there are 7 people in your car, collect information for all 7 names, 7 addresses, and so on. So this is a bug that came in. They said there's a bug in the workflow. If there are 7 people and the user is driving, that means there are 6 passengers, but only 5 passenger screens are displayed. So this is a pretty typical, we've all been here. We've all had this sort of issue before. And it's the sort of thing that sounds like really easy to write a UI test for, right? This is what UI tests are for. So there are 7 people in our car, user's driving, and we should expect 6 passenger screens. So how bad could it be, right? This is going to be really easy. Not so much. So let's talk about the first step here, and that's actually as far as we're going to go, believe it or not. So there are 7 people in our car. Well, how do we write a UI test for this? Well, if you've done UI testing before, what you have is on iOS, you have a UI text field. And that UI text field is going to have an accessibility label, right? Because our test infrastructure needs to know sort of what field you're going to operate on, and there may not, it needs some machine readable identifier that it can find. So that's what's used on iOS. And it's right there, interface builder. So that's where you type it in, create your field. And the user types in 7, and that's it. That should be really simple, right? What are we forgetting? I'm sorry? Expected result. Okay, that's true. Another thing that we're forgetting is whether or not we're on the right screen, right? Because when you run UI tests, you got to make sure that you're in the right place, because the test starts in an invalid state. Some other test failed, and so that's like a really important problem. You got to maybe go back through your user interface to start at the beginning. And so we need some way to like say, oh yeah, we're on the right screen. So the way we do this is we start with the user on a screen that has a UI navigation bar, and the topmost view controller has a UI navigation item. There are a lot of sort of iOS specific details here. The UI navigation item has a title, and the title is accident report, and all the stuff on the previous slide. So now we're done, right? No, we've just begun. So yeah, Americans tend to forget that not everybody in the world speaks English. And of course, a lot of the strings that we're matching on are English strings. Of course, that's not always true. And And it's also not always true that users are using English keyboards. A lot of the testing frameworks that exist are designed for English keyboards, which is a problem. It also sort of makes you wonder why we're using a keyboard to type in a number. Doesn't really make sense. And what's probably happened here is nobody's thought about this requirement, which was sort of true in my case. Nobody ever thought about how you should type this in. And so the boss comes in and says, you know what? We should be using a UI picker view, which would be a lot better. You know, one of those spinny things. If you're an Android developer, you know what I'm talking about, the slot machines, right? And so I've gotten this far, and somebody has said, hey, wait a minute. This isn't a testing problem. You need to have your requirements sorted out before you do testing. And so you know, if you don't have your sort of requirements nailed down, then that's not UI testing's fault. That's, you know, a problem with your process. But if you believe that, you're probably at the wrong conference. This is we don't use waterfall methods that much in iOS development. We tend to use more sort of agile responding to change type methods. And of course, that's in the Agile Manifesto, responding to change over following a plan. And what I would tell you is if your test methodology makes change hard, it's broken. So that's like feature one, something you should be thinking about when you're coming up with a test strategy, is to make sure that you're ready to respond to the arbitrary whims of whoever shows up and says, you know, here are the requirements that, you know, requirements change, deal with it, kind of thing. And that's pretty true because most iOS software is kind of experimental. It's, you know, done rapidly. We're sort of figuring it out as we go along to some extent as an industry. And so it's really important that your test methodology is prepared for that. So, and these are all real things that happened in this project, by the way. Like, this is like the actual thing that occurred. They said, well, you know, this slot machine control, you have to put your finger down at a particular position, and you have to hold it, and you have to move it a precise distance, and you have to lift up, and that's a lot of work. So what we should do is we should just have a UI table view with check marks, which of course is completely different than the implementation we had before and the test that we had before. There's also a really persnickety problem with this. And if you have never done UI testing before, you might not know what it is, but probably someone in this audience knows the problem with testing UI table views. Maybe? Maybe not? Yes. Yes. So the way that table views work in iOS and in, you know, for performance reasons, the UI controls don't exist when they're off the screen. So all those table view cells are all recycled. And so as a result, if you're looking for like 12, it doesn't exist. It's not in the user interface. You can't, you know, parse a UI hierarchy and go find it. It's not there. So figuring out how to write test code that, you know, is prepared to scroll UI table views is very difficult in the general case because oftentimes they're not sorted or not sorted in a way you expect. So you might, you know, be dragging your UI table view for quite a while. And most of the UI testing frameworks basically punt on this problem because it's too hard. And we'll see some of that code. So yeah, maybe that's not a good idea because it takes up too much screen space. Users want more controls on the screen at once, right? So we should use a UI stepper. And it's also you know, something that's closer to how people think when they're sort of tallying up how many people are at the scene. 1, 2, 3, 4, 5. Sort of a good logical mapping to using a stepper and, you know, pressing a button. Sort of a logical decision. And so this was like the sort of the final decision that was made on this product. Of course, each of these implementations were actually tried, and tests were written for them, and they broke each time. And this will probably happen to you. So you think you're writing sort of a very simple. This looks very simple, right? We have 7 people in the car. The user's driving. Should expect 6 passenger screens. What you're actually writing is a very long, boring novel. So, and you know, something else that's kind of concerning is that everything in your app is coupled to this test. So this particular test, this particular app, you have to know how many people are in the car in order to do just about anything, right? It's one of the first questions that you're asked. And there's probably some control in your application that's first. So if you're, you know, writing an application, there's probably some bottleneck for you. And it's also the the most likely thing that will change because it's important, it's critical to your application, and so the designers and the project managers and the people who talk to users are going to want to iterate on it. And so you have to be prepared for this, and that's very difficult. And of course, all this time we've just been talking about this one text field, and hadn't even gotten to any of the other steps that we would need in order to implement sort of a robust test case for this bug that has nothing to do with this text field. We know the text field works, hopefully. What we don't know is whether or not it shows the right number of passenger screens, and there's a long distance to go before we can determine whether or not that's true. So what actually is happening here is when you write a test, you are creating a contract, whether you like it or not. So yeah, here's something you should write down in your book when they ask you, what was this talk about? You can tell them every test is a contract. So what does that mean? Well, a contract is supposed to look like this. This is an itWithArray. It's a method call in iOS. This tells you several things. It tells you what you can do. It tells you what you need. So you need a array. It's the parameter for this method. And it tells you what happens. You'll get an array. And it also tells you some things about the array that you get. Is it mutable? Can you perform certain operations? All that's included in this documentation. And most importantly, if somebody changes this, you'll find out, right? Because there's a process in place when there's an API change. You get an API diff, new version of iOS is released. If this API goes away, maybe you get a deprecation warning. Maybe your project fails to compile. These are all things where you find out. It's not a secret. It's not a mystery. It's not, I wonder if this will break existing applications. And so there's quite a lot of resistance to changing APIs like this. But when you do change them, you know sort of what you're in for, which is not true with user interfaces. So this is a terrible contract, right? This is a user interface. There are a lot of problems with this. One problem is that it's not really clear if I can tap those or not, right? So they're dark. They're dark in different colors, and that's often something that's used to indicate like a disabled control. And so, looking at this as a user, right? Even more looking at it as a machine, as a automated testing framework. There's no way to determine whether or not that's can you tap there? Should something happen? I don't know. So another good question is how do you enter text here, right? We covered this with the how many people are in your car problem. There are a lot of options, right? A keyboard could come up, a date view could come up. There's a whole lot of possibilities, and your testing framework is going to be unprepared for the kind of data that you want to enter there. Another good question is, can evening happen before morning, right? So as a human, we look at this screen and we say, well, morning, day, evening, I understand what those words mean, and all the times are in order. But if you're a automated testing framework, it's not really clear what should happen here. It's not really clear whether or not the data that you're trying to enter is legal. And so it's very difficult to solve these at a library perspective, right? You can only solve it from an application level perspective. And of course, your test relies on implicit, undocumented answers to these questions. They're implicit because nobody has ever made a decision that this should be the case, unless you have a really good spec, which you probably don't in a 5-person company. And nobody will ever find out if these assumptions change. There's no process. You don't get an email and say, hey, I think this should be different. And all the engineers find out about that Monday morning. There's no change control process for this. So as a result, your tests break. Somebody, the designer goes in and changes something, and all of a sudden you have a set of failing tests. This isn't a contract either. The user tells us that there are 7 people in the car. How do we know that? Well, I don't know. By some process, the user indicates this information to the application, but that doesn't tell us how it happens or what we should expect. And this is really the condition that we're trying to test, right? We're not trying to test whether or not a keyword works. Hopefully we know that, right? We're trying to test whether or not the user told us that there were 7 people in the car. But you can't do that because it's not a contract. So if you find yourself looking for automatic UI testing, maybe instead you should have been looking for how to learn to write testable code. John gave a great talk about this before lunch. This is like a method that probably should have existed in my application. A method that returns how many passenger screens to display, given the parameters that were in the bug report. And if this method existed, I could write a unit test, and that unit test would be the same every time, and it wouldn't change if the UI changed. And every time, the manager came in and said, I want to use a table view now, this wouldn't be affected, and the test suite would continue to pass. And this is also robust to a large number of other problems that we're going to talk about. And of course, this is an actual contract, and actual contracts can be tested. So the problem really isn't automated UI testing, right? That's sort of the thing that we maybe thought going in, right? This looks like a problem for Kif. This looks like a problem for Frank. In reality, a method like that would have been much easier to test if only we had written it. The problem is actually unit testing, but we didn't see that because we didn't write testable code to begin with. So oftentimes, when you find yourself reaching for Kif, Frank, or whatever, it means that it's because you need a unit test and you didn't write testable code to begin with. So when you find yourself reaching for the UI framework, stop and think about, hey, wait a minute, is there some way that I could have unit tested this and I didn't because I wasn't thinking about it? You can't test quality into a product, right? So oftentimes this is an indication that the quality is bad. You've written bad code, and now you're trying to fix it by adding tests, and that doesn't work. You can only fix it by fixing it. So write good tests to begin with. So another problem is that our tests are often brittle, right? They break. And so as a result, here's some scary code that's in your UI test suite right now. So this comes from Kif, right? We have a keystroke delay of 0.05f. And so we assume that the keyboard takes that long to execute a tap. Is that true? Is that documented? No. It's just what Kif decided works. And this should frighten you if you're running a continuous integration system, because maybe it took a little longer today. There's no guarantee about how long this is going to take. And actually, if you search for constants in Kif, there are a lot of them, and this should frighten you. This should really frighten you, and they're all different, and very few of them are documented. And so somebody just, came up with, 0.3, and it worked, and like that was good enough. But not all the time. So sometimes you get comments like this, where they tried a number before, and well, some people reported it as a bug because their machine is slower. So we're just going to increase it by some and hope that that's good enough. And if you're running a continuous integration system, this should frighten you. So here's another good example. This is code in Kif. They're looking for a view with accessibility label choose photo. I hope you speak English. I hope your tests run on an English language iOS device. Here's another good one. The combination of select row in component animated and tap does not consistently result in pick review did select row in component being called on the delegate. We need to do it explicitly. So what's going on here is sometimes the system decides to call this callback method, and sometimes it doesn't. So Kif just does it. And so as a result, sometimes this method will run once, sometimes it'll run twice. It's up to you. So this should frighten you. Here's another good one, right? So this is a code to look for a album in the image picker, right? So there's a Kif test step that does this. And what it does is it looks for the items in the grid have accessibility labels with the name of the album. But they don't have just the name of the album. They have the name of the album, followed by a comma, followed by 2 spaces, followed by left open parentheses. And so I hope this is true in future versions of iOS, because if not, you'll find out when your tests fail. So these are good examples of sort of scary things that happen in UI testing frameworks. And it's not because the people who design Kif are bad or bad engineers or anything like that, right? These are really the best ways to solve the problem, right? The problem is hard. And there's no really good way to create a machine that can solve, it can look at a user interface and understand it and make sense out of it. And there are places where Apple has made it difficult to do that. And so as a result, this is the best you can do. But just because something is the best that you can do doesn't mean you should do it, right? And so just because this is the best way to figure out how to test the UI image picker doesn't mean that that's a good idea. And so your only option is this. I would recommend doing nothing because this is going to break. So the theory is as follows. When a test fails, we know something broke, and we know who broke it, right? This is why we have things like this. So this is a
someone broke the build.
Continuous integration system, and we've got a developer here who's broken the build, and
You broke the build, Tom. Either that or you're listening to Kylie Minogue too loud.
so this is how we think about breaking the build, right? We have a culture against it, don't break the build. And so the idea is, well, we have a test suite. The test suite tells us whether or not the software is good. If the test suite fails, then we know something's wrong, and we can go fire missiles at our developers or whatever is the exception handler at your company. However, that's not true. So the reality is there are a whole list of reasons why a UI test might have failed. One is that maybe the gesture took slightly longer than usual, right? So for some reason, iOS compositor came back late today, and that can happen because 0.05f is not long enough for everyone all the time. Maybe an animation took slightly longer than usual, so somewhere deep in core animation decided to take longer today. Right? Some network requests took slightly longer than usual because unlike in John's talk where we're doing unit tests with mocks and local things, there can be strange things that happen on the network. Maybe the server came back with an error today, right? So it's not even our fault as iOS developers, but like somebody else screwed up and so the build fails, right? Maybe the server is gone. Okay, so I gave this talk and a guy came up to me afterward and he told me, okay, I have the greatest build failure story ever. You have to hear this. And I said, okay. And he said, all right, here's what happened. I had a build, failed, didn't know why. Traced it down to the network, right? So something's, the server's just not responding, right? Trying to figure out why. I call the data center, right? Can't get through the data center, right? I call like the backup engineer, can't get through to the backup engineer. It turns out that this was September 11th, 2001. And the machine that caused a build to fail was in the World Trade Center and no longer existed at that point. So this is probably the only build that ever failed due to a terrorist attack. It can happen to you. So, have your, be prepared for this, right? Be prepared for strange things to happen to your build cycle. We're not done. Some codes somewhere in your app got slower, right? This one is great because most of the time when you're doing a build, it's because you've added code. And when you've added code, more code normally takes longer to run, typically, right? And so this one is probably true. Like it's probably true that some code somewhere in your app got slower. And the only question is whether it got slow enough that it's going to cause some timeout in your test suite to fail, that it's going to cross that threshold into, I'm sorry, I waited, 3 seconds and I didn't get a response. So this one is particularly dangerous. Some UI element somewhere in the app changed, right? This happens a lot in iOS products, particularly for very important controls that are, right at the center of the action. We upgraded Xcode, right? And who knows what happened, right? New version of iOS. Your album name is no longer comma, 2 spaces and a left parentheses. Who knows, right? Gremlins, I love these. These are, a lot of my build failure messages are gremlins. The previous test failed, possibly reported as a pass, and so the test started in an invalid state, right? So it's some other test that failed, but that was reported as a pass because nobody checked the, is it actually supposed to pass condition well enough, like the gentleman said earlier. And so we have a test failure, but the test failure we have is a lie, right? It's some other developer who is at fault, and good luck. Or maybe there's a real bug in your code that's being reported correctly. Right? So we like to think that this is the only explanation, but the reality is with UI testing, it's not the only explanation. It's not even the most common explanation. So this is from Mozilla. They say currently our intermittent oranges, which are what they call tests that sometimes pass and sometimes fail, are not very interesting. After they've been identified, they're usually more or less ignored. This has caused us to accumulate oranges to the point that we have to deal with several of them for every commit. And by deal with, I mean log in and forget it, which is a time consuming for the sheriffs and for anyone who pushes a commit. At the same time, it demotivates any effort to actually fix them. This is what will happen to your UI tests if you're not very, very careful. And if you don't declare war on Orange, you will discover that you have spent time and money building and maintaining a test suite that tells you nothing. Right? You've done all this effort, you've kept up with the UI changes and the pointy-haired boss who keeps pushing down new requirements, and as a result, you have a test suite that fails every single time, and different reasons, and you're not sure why, and who knows, right? Gremlins. And so one thing that I've actually seen people do when they get into this situation is they just keep running the tests until they get a pass, right? Which is all kinds of ridiculous. First of all, if you really have an intermittent issue, then you won't see it. And yeah, so that's kind of nuts. So key insight number 3, your test results are more often wrong than right? Because it's much more likely that when you get a failed test, it's because something to do with your test rather than something to do with your code. Why is this? Well, it's very simple. If you have 7 tests, and each of those tests has a probability of being right of 0.9, and all the probabilities are independent, which is, probably okay, then your test suite only passes 47% of the time. So you have a test suite that each of the tests individually are pretty okay, but the build always fails or fails half the time, and there's no real reason, there's no consistent explanation, there's nothing wrong with your code, and you've received a failing grade on your test suite. Did I get that right? Maybe? Hopefully. Excellent. All right. So there's a funny thing about user interface testing. It contains this word user, right? Which we forget because we abbreviated automated UI testing, and we've just forgotten that there's the word user in this phrase. Now this is what a user looks like. I don't know if you've ever seen one before. If you're sitting in your cubicle, you may have never spotted one. This is not a user, right? And get this, it can't test a user interface, right? It can test something, but it can't test user interface because it's not a user. It doesn't understand how users think, doesn't understand the controls, doesn't understand anything. All it understands is the contract that you create, whether it's explicit or implicit. And so, if you're looking for automatic UI testing, you might be looking for a QA department, right? So maybe what you need is, actual QA engineers who are, prepared to test user interfaces. And key insight number 4, don't take the user out of user interface testing. So this is, again, something that a lot of smaller companies believe is they can, fire all the QA engineers or never have to hire them because they can just write tests, and because, we're developers, we're brilliant, we don't need anybody else. And so we just write the tests, keep them forever, and they run on every build, and, it's always green, and nothing bad ever happens. But computers test computer interfaces, and users test user interfaces. Don't get them confused. What happens is you have a bad user interface. And when you have that bad user interface, that sometimes leads to a bad test, right? Why? Because user interfaces are very difficult to test. You have to rely on accessibility labels and, is that table view on the screen and all kinds of other things. And you don't want to break the build, so you don't change user interface because that would break the build, and breaking the build is bad. You don't change the test because that would also break the build. And so what this creates is a huge amount of inertia to actually fix anything, because you have sort of a structure that enforces like the status quo. And as a result, you have a black hole, your whole project gets sucked in, and this has happened way too many times. Steal my startup idea. So you've heard of Mechanical Turk. It's a Amazon web service. I don't know if it's a web service. Amazon service that allows you to programmatically assign tasks to people, right? So you pay like 5 cents, and somebody does some small human task for you. What I want to do is I'm never going to do this, but this is like one of my ideas in my notebook, is you create a web app that has like a running iOS simulator that's hosted in the cloud somewhere. And you just ask the user, like, there are 7 people in your car, make an accident report, like, does it work? And you just ask them, like, yes or no, and like, why not? I don't know. So, like, this is a thing that could actually work. Why? Because the user is testing your user interface. And users are prepared to deal with when controls change from table views to UI pickers. And they're prepared to deal with, network errors and stuff like that. So here's some good news. Automated UI testing can work when it augments your QA staff instead of obsoletes them, right? So there are many companies that actually have QA engineers, and what happens when you have QA engineers is they sometimes have to test everything manually, right? And so you can get a significant savings if you can get 10, 20, 30, 40, 50% of your testing done automatically. All right, that's a significant win for an organization that has like a QA department. But what happens is developers, software developers at small companies see this and they say, oh, I can use this for everything, right? I can get 100% UI code coverage. And so the experience is the same, but the expectations are very different because a company that has a QA department goes into a framework like KIF or Frank or whatever, and they go in with the expectation that this will save them time, and it does, because now they're only testing half of the stuff manually, and they used to be testing all of it. If you go in with the expectation that you don't need any testers, it's not going to go as well for you because you don't have somebody to sort of manage those exception handlers when the automatic testing doesn't work. So automated UI testing is a good tool to sort of speed up your manual QA process. But if you think of it as a sort of solution to all your problems, it's not going to happen. Automated UI testing can work when a human interprets whether or not a test passed or failed, right? So you run the test suite, right? It generates an email to the QA lead, and he says, okay, here are the things that I should go test because they're reported as failures. Like, did anything change, right? And so that human goes in and says, all right, there's a build failure reported here. Is that real or is that gremlins? And so goes in and look at it and interprets the test results, right? So that's something that can work. But again, that's not the expectation that a lot of smaller companies have. They want an automated system that'll fire missiles at developers when they get it wrong, and you can't do that. When you plan to frequently rewrite tests to respond to changing requirements. So if you go in and say, look, these tests have a shelf life, right? They're going to last a month, 2 months, 3 months, whatever the case may be. We're going to rewrite 25% of the tests with each release. If you go in with that mindset, then you'll be fine. But if you go in with the mindset of we're going to write this test once, it's going to stay there forever, it's going to continue to pay dividends indefinitely, it's an investment, then you're going to be disappointed because that's not true. You're going to end up dealing with changing requirements, and you've got to make sure that you adapt your UI tests to deal with changing requirements, and you don't get stuck in the black hole of I have a bad test, I don't want to break the build. I have a bad user interface, I don't want to break the build. So, and automated UI testing can work to provide that last 10% of code coverage that could not be unit tested, right? So, again, when you're reaching for KIF, when you're reaching for Frank, oftentimes it means that there's a unit test that you didn't write. You didn't write your code in such a way that unit testing was the obvious solution. And you can't unit test everything, but you can unit test a lot of things. And most software developers who either have never practiced TDD before or maybe are skeptical about it don't necessarily write code in a way that lends itself well to unit testing. And so oftentimes that's the source of the problem rather than UI testing per se, that you're using the wrong tool for the job. And that actually plays into why there are so many UI testing tools out there, is because there are so many people who try a UI testing tool and it sort of fails to pay off in all the ways we've described. And rather than saying, you know what, I sort of made some mistakes as a software developer, I should have written more functions that were more individually testable, they say, well, the problem is the UI testing tool I was using, so let's create a new one that is a little bit different than the ones before. And that's why we have so many. We don't need any more. So yeah, sometimes that last 10% of code coverage, that last mile, once you've sort of moved everything down into models code, like John was talking about earlier, once you've done that, sometimes you've discovered that you don't really need UI testing because you're able to do all the things that you wanted to do with unit testing. So, and that's often the case, unless you have unusual testing requirements. So yeah, let me open it up to Q&A. Any questions? Yeah. let me sort of run a mic over there.
Hi. So basically, I heard the thesis that you have talked about that sometimes it's even better to do nothing at all rather than do
Yes.
things, and you stick to this idea, right?
Okay. You're interested. So you're interested in the idea of
basically,
why
because
it's better to do nothing.
I do agree to the point that this is really hard to test everything with the
Right.
UI testing, and I'm actually a big fan of it.
Right.
But for example, let's assume that you have, for example, you have your team, you have 4 developers,
Right.
you have 1 or 2 QA engineers,
Right.
and this, how do you assess? Is it depend on the project size when this comes to a value? Because the first problem is to convince a product owner on someone on the higher level.
Right.
It really gives a value. This is
Right.
pretty obvious.
Right.
And there is a time spent on instructing people how to work together, to cooperate together to get these all things running, because there are different responsibilities when you write the code, even
Right.
if it's testing code, and instructing the QA engineer how to actually cooperate in this
Right.
constellation.
Right.
So my question is basically, do you think it is dependent on the project size when this comes to a value, or not really?
I think it does depend on the project size. I think it also depends on the team size and the competence of the other developers and QA engineers that you're working with. One of the things that catches software developers off guard is so many testing frameworks are written in languages that are wrong for the environment that you're working in. For example, in iOS, there are very few testing frameworks that are written in Objective-C. And as a software developer, that feels very wrong, but it's also a clue. The clue is that the customer of UI testing packages is often not a software developer. It's a QA engineer, right, who are more comfortable in languages like Ruby or whatever. So if you find yourself drifting towards, I am working against this because it's not Objective-C. Oftentimes that's a clue that you're sort of stepping beyond the bounds of what UI testing can do. But I think it does vary. I mean, each project is different and has, each industry is different. There are industries that are tightly regulated where you need to have, correct code if you're doing, flying planes around or, military applications, stuff like that. The value proposition of testing is very different than it is if you're writing a consumer application. And so, that's an area where I think it's probably good to run experiments, write a couple of tests and, say, well, can we measure how much time we saved, or can we measure, what the cost of doing that was?
Yeah, basically this is the point that usually in the customer environment you don't have so much time for experimenting.
Yes.
And the second problem is usually the customer do not see really value in your code should work just fine, and even if it's not a customer, it's sometimes up to manager just to deliver the app.
Right.
Do you have any ideas how to sell it better?
I mean, so there are some problems where the solution is to work with different customers. Right? I mean, so there are some cases where, if you have someone who's like really opposed to any testing, who's like, I don't understand like unit testing or anything, like that's maybe a customer where you say, well, like I don't know if sort of I want to work with you. So I think there's like a level of that. But I think also, most people, I think, are convinced by evidence and are convinced by, good reasoning. And so, maybe you start with one project, and then you have a case study, success story or something, and you move on to another project. But I think also, with UI testing in particular, I think there are sort of a lot of failed examples. I've worked on many projects like this insurance project and others where there are unreasonable expectations about what UI testing was going to do, and maybe unit testing would have been a much better fit for these kind of problems. And so, yeah, I think just because I think sometimes we have to be humble as software developers, because just because we think that UI testing or like some new thing that we learned is going to make the product better, it's important to measure and like validate that that's actually true. And so maybe if you have a side project or you have clients who are more willing to be risky, like that's sort of an area to explore and start there, and then you have a case study of that going well. I'm gonna flip this back so I can see you guys better. That really lights up the audience a little bit. Did that answer your question?
Yeah, basically yes.
Okay. Anybody else? Got one somewhere, maybe over there.
Hi, thanks for your presentation. I have one question. Do you think that right UI testing framework is still to be seen, or there is no point in creating one at all?
I mean, I think we have so many that I can't imagine any feature that's not covered in a framework that already exists. Like I said, there are like some places where I showed in the slides where like this is crazy code, but I mean if you think about it, I'm not sure that we could do any better, right? I mean you need to have some keystroke delay because that's not documented how long a keystroke takes. There's no event you can listen for or anything like that. So it's sort of difficult to imagine how to improve those kind of things. And I think sort of what's led to the explosion in UI testing tools is maybe people who I think are looking in the wrong place, right? Oftentimes the problem is unit testing. It's not writing testable code. It's not having functions that they could write tests for instead. And it's easier to imagine it to be somebody else's problem, this UI testing framework that I worked in, like they're at fault, because that's a much easier thing for us to believe than that we're responsible for making our own mess. And so yeah, I don't really see any way that UI testing frameworks could improve. I think some are more mature than others. I certainly wouldn't advise you to go write another one. Maybe if you have an ideas for improvement, maybe find a existing project and try and improve that.
I apologize for the comment and not the question. So commenting on the last thing, I think the improvement can come not in the tools, but
Right.
in how you write your tests. Specifically, as an example, instead of directly targeting a control, you instead extract a little helper method that says to target that control. Then you don't have to change that in 50 places when your button moves.
Yeah, and that's very necessary, and that's like in this how many people are in your car, like that was true the whole way, right? There was always one implementation for adjusting that control, which had to be done on every test. But even sort of keeping up with the sort of failure modes in that control was a lot of work. And so like it's really important if you're doing UI tests, exactly what John said, to make sure that you've sort of have refactored very clean code. But even then, you should still expect there to be some problems. You should expect Murphy's Law. Should expect bad things to happen. And there's really no escaping that with UI testing because it is so brittle, and it's there's so many server could go bad. The thing could take longer than we expect. So many things that could go wrong, and that's why I think unit testing is a really good alternative in many cases, because it eliminates a lot of those sort of externalities that could cause your build to fail through no fault of yours.
Thanks for the nice presentation. My question is, if you do decide to start UI testing,
Right.
Which approach is better? Actually testing screenshot based or introspection based? And in the same manner, whether it's better to record users' touches instead of some sort of scripting.
So that's a great question. Let me try and handle both parts. So to the first part of your question, whether it's better to sort of look at user interface or whether it's better to try and do introspection, I think it depends a lot on the type of application that you're writing. For the insurance app, which is sort of a flow of different screens, I think it's better to use introspection because it's likely that things are going to move around a little bit, but maybe you can have some anchor points like the title of your screen and so on. Like you can rely on things like that. There are applications I've worked in where they're like visualization, so like visualizing a set of data, and so the goal then is to sort of create, like, you import a data set and then it draws a picture. And so in those cases, it's better to sort of look at the picture that comes out, like instead of rendering it to the screen, render it to disk. Maybe even check it into source control and use like GitHub to sort of see like, did something change, slide it around. You have to be careful with those because oftentimes things can change and it's not necessarily a test failure. So if your visualization is a little bit different, like maybe that was a design choice, or maybe like the two visualizations we get are equivalent, like it doesn't really matter which one it is. And so comparing the pixel values are not necessarily reliable to indicate a failure. And so that's sort of an area where, depending on the project, it might be a good idea to insert humans into that process and to look at the picture and say, like, all right, is this picture a regression? And so like those kind of things are really useful, and I've done that on sort of visualization-based projects before with a lot of success. Let's see, the second part of your question I'm trying to remember. Sorry. It was about what? Input. Right. Okay. So for the most part, I would recommend scripting the input manually, and this is because on like on the insurance project I showed you, things are likely to change pretty often in particularly in iOS or mobile work. You're not really sure what the right user interface is when you start. If your project is more mature, then maybe collecting input is a better possibility. But I think developers often overestimate what the likelihood of change is going to be, underestimate what the likelihood of change is going to be. And so I think it's often better to play it safe and assume that things will change, and you'll sort of be maybe surprised by how much that's not the case, rather than imagining that nothing's ever going to change and then waking up Monday morning when your boss comes in and wants a UI pick review. Other questions? I don't know how much time we've got. Got a little bit of time, I guess. We good? All right, I will be in the lobby here to answer your questions. If you want to know anything about testing, you want to know anything about continuous integration, you want to know anything about iOS, I know a lot about iOS in general, core data. I could probably, if I don't know, I could probably find someone who knows. So yeah, but thanks for having me. Poland's been great, so thanks so much to the organizers. It's been wonderful, and thanks for showing up and listening to me complain.